All right, let's look at the homework 1.5, problem number 9. All right, so it says this. So we're talking about the bacteria population, and it says that it is known to double every 3 hours. Suppose that there are initially 110 bacteria. All right. So what is the size of the population after 15 hours? So it's so you start out with let's see, 110, and then you multiply by, right? So after 15 hours, how many times it doubles? Right. So every 3 hour it doubles. So it's going to be, so within 15 hours, it's going to be 15 divided by 3, right? 5, it's going to double 5 times. So you do 2 to the 5th power, right? So let's compute that. I'm going to just cheat, bring out a calculator, all right? And I'm going to just compute, let's see, oops, get out of there, all right? And then it's going to be 110 times 2 to the 5th power, right? Then hit enter. All right, so 3,520. So I'm going to just put 3,520. All right, so that's part A. All right, what is the size of the population after T hours? So what we did was we start out with 110, and then we multiply by 2 to the, I remember that if it's 15 hours, it doubles 5 times. So you just have to divide by 3, right? So if it's T hours, you just have to divide that by 3. Right, so it looks kind of bad, so maybe I'll write it, hopefully it'll accept it. Right, so this is the population after T hours. All right, so what is the size of the population after 22 hours? All right, so we can do that. So it's going to be 110, right? Then multiply by 2 to the 22 over 3, right? So let's say I'm going to have to put the parentheses here. All right, let's compute that value. So it's the nearest whole number. All right, so we're going to put the 110, all right, times 2 to the 22 hours, but you have to divide by 3. So divide by 3. All right, so here. All right, so the nearest whole number is 17,739. Oh, so it's going to be 40. All right, so 17,740. All right, so that's part C. All right, part D, we want to find the correct picture. All right, so I'm going to cheat a little bit here. So I'm going to go to y equals, then type in the formula 110 and multiply by 2 to the, in this case, I'm just going to use x here, divide by 3. All right. Then window size is going to be, I'm going to make it big enough. So I'm going to go for x goes from 0 to 50, and y goes from 0 to 160,000 or something like that. And then hit enter. All right, then graph. All right, so hopefully it gives you the picture here. All right. So let's see, which one is a reasonable one? So this is around, so this is 50 right here. So this is around 30-ish. So let's see, I can't see it. All right, so it's probably, this is the closest picture. So I'm going to pick that. All right, and the last question, estimate the time for the population to reach 150,000. Round your answer to 2 decimal places. All right, so if you look at the graph, right, here's the graph. So this is the population. So we want to hit 150,000. So I'm going to go in. So I'm going to draw y2 equals 150 thousand. All right, and then try to graph that. All right, so this red line is 150,000 line, and we want to know the time there. So this is when the population hits 150,000. All right, so what you can do is the graphing calculator has a nice function here, second trace, which means calc, and then we can find intersection. So I'm going to just say find the intersection. All right, so first curve, yes. Second curve, yes. And the guess, I'm going to just try to move it closest to the point here, then enter. All right, so it looks like intersection it's kind of hard to see. It's a 31.239, so 24. So it's 31.24. 31.24. All right. So let's check the answer. All right, I came back and looks like we got all parts correctly. All right, that's it. I hope that this was clear.